So here we have another log graph. Just looking at it quickly, we will ultimately talk about graphing it on the calculator, but we see it's a regular log graph, but it's been shifted 1 to the right. So if you go in your calculator and make a little table for this, you will see that at 0, there's an error. At 1, you will also see an error, and at 2, we're going to see that the value of the graph is 0. And a general shape of the graph is going to look like this, where we have a vertical asymptote. It looks kind of like 1, but that value is at x equals 2. So the x-intercept, so we want to know which one is false. So just be careful with those, kind of backwards questions. The x-intercept is 2, 0. That is correct. It does cross the x-axis at 2, 0. It does have no y-intercept. It has a horizontal asymptote. Okay, that does not look true. We have a vertical asymptote. All log graphs have a vertical asymptote. The range is the set of all real numbers. We see the arrows go down and they go up, right? So that is true. So 3 is the one that's false. So even if you were having trouble with what does an asymptote mean, you can tell the other 3 are true. So therefore choice 3 has to be false. So here's our next equation. We have g of x and we want to know when it's equal to 22. It does say we have to use algebra on this one. So the first thing I'm going to do is move over the 3. And I get 25 equals 1/5 to the 2x plus 7. So now I want to make the bases the same. So 25 is 5 squared. 5 is 5 to the negative 1. They're both powers of 5. And this is also raised to the 2x plus 7. Cancel the 5s and we get 2 equals, we have to distribute here, negative 2x minus 7. So then we're going to move over the 7 and we get 9 equals negative 2x. So dividing by negative 2, we're going to get x equals negative 9/2 or negative 4.5 for that one. Remember, we're just looking for an x value there. We're trying to say when does it. We already know the y is 22. We're trying to find the x value. So the next one we have a graph. Also something you could do on your calculator. We'll talk about how to do it by hand as well though. So it says on the grid below, the graph of f of x equals 2 to the x is shown. So on the same graph grid, create an accurate sketch of the function's inverse. Now to find the inverse, all we have to do is take points on the function and switch the x and y. So here's the point 0, 1. So we're going to graph the point 1, 0. Here is the point, we'll do 2, 4. So we're going to graph the point 4, 2. Notice I'm not negating anything, the signs stay the same. Now, just like this graph, which is an exponential graph, goes very close to the x-axis. It looks like it touches it, it doesn't. It has a horizontal asymptote at x equals 0. This graph has a vertical asymptote at y equals 0. Now, since we're graphing it, we're going to make it so that, I'm just going to put one more point on here and get that curve a little better. So we also have the point 3, 8. So we're going to graph 8, 3. We want to make sure, since we're drawing the graph, that we do not cross that vertical asymptote. Now to find the equation of the inverse, I'm going to take the original function and switch x and y. So I get 2, actually we'll cross this out and make it a y first. So I get x equals 2 to the y. Now this is that equation where we could try a bunch of things to solve it, like trying to get rid of the y, but ultimately the best thing to do is to put it into log form and really the only option. So this is Ben, and we want to go to log Benny. So log, the base is 2, the number is x, and it's equal to the exponent, which is y. Now I ultimately want to write it in inverse notation, so f inverse of x equals log base 2 of x. So the next one, it says, given the equal terms, the cube root of x to the 8th, so we're saying they're equal, and y to the 4/9, we want to solve for y. Okay, state y in terms of x, that means solve for y. So first I'm going to put the left side of the equation in exponential form, 8 over 3. And then I'm going to raise both sides. I want to get the y by itself, so to cancel out the 4/9 power, I'm going to use the 9/4 power. Here I'm going to multiply my exponents. That gives me 72 over 12, which actually equals 6. So this is y in terms of x, or we've solved for y in that equation. The next one says, is x to the 2/3 to the 4th equal to the 12th root of x to the 8th? Explain your reasoning. So the first one, we multiply the exponents because we have power to a power. So that's 8/3. This one, it's 8 over 12 because the root is 12. So these two are not equal to each other. And we could just write they are not equivalent. Because the exponents are not equal. Kind of a weird one to explain. Really, where the 8/12 came from was someone making a mistake by multiplying the 2 and the 3 by the 4 here, so you would get 8/12 over there, but you can just make a statement about the math that you did.